One of the most important things behind Linux containers are kernel namespaces, and they are responsible for different kinds of isolations. If you just want to run simple containers on Linux without Docker desktop, and if you are lucky, everything will just work. Unfortunately, we are not living in a simple world like that, so eventually you will have to face some issues, and I believe network issues are the scariest of all. So learning about Docker network and the network namespace now can save you a lot of time in the future, even when you are not using Docker. I'm Ákos Takács, and I'm here to show you what you absolutely need to know about the network namespace. Let's say you have a process running on your host operating system, and in my example, I will use a PHP process, but you can imagine anything else. And that PHP process can see almost everything on the host, including the file system and the other running processes and also the network interfaces. And the bigger problem is not that the PHP process can see those interfaces, but it can also listen on the IP addresses available on the host. And if the PHP process listens on a public IP address, then your website could be available from the outside world. This is when you want to use namespaces, and I will only talk about the three best known namespaces, and these are the mount namespace and the network namespace and also the PID namespace. I will also mention some other namespaces as well, but these are the main namespaces that I want to talk about. The first namespace I want to talk about is the mount namespace, and you may remember it as a jail or chroot. It means you will have a subfolder on the host operating system, and the PHP process will see only that folder and nothing outside that. You can also create files and folders inside that subfolder, so you can make it similar to an actual root file system. If you do that, the PHP process will see everything as it would be on the host operating system, so it can access any configuration files and libraries that it requires. Sometimes it is not enough and you want more isolation. And this is when you can also use the PID namespace, the process namespace, which means that your PHP process will not see any running processes on your host. It will think that it has a different machine, and this is the only process running on that machine. Since a Linux operating system always has a process with PID1, the PHP process will get that ID. But that ID will only be one from the container, from the process namespace. And if you are looking at it from the outside, from the host operating system, then it will be a much larger number. So what we did before, we made the PHP think that it was running on a different machine from the file system's point of view and also from the process's point of view. And now we want to do the same with the network. So we can use the network namespace, and the PHP will have its own private IP address, which can be used to communicate with the outside world and other containers as well. But it will also have its own loopback interface, its own localhost. The PHP process will not see every IP address on your host, only the IP addresses available in the same network namespace. These namespaces are completely independent from each other and completely independent from the PHP process. The PHP process does not own these namespaces, it is just using them. Namespaces are actually like just huge walls that can cover the host operating system from some point of views. You can use multiple walls, multiple namespaces to hide more parts of the hosts from the PHP process. So what is the relevance of the independence of the PHP process and the namespaces? You can actually use any program available on your host operating system and run it in any namespace. It means you can also use curl installed on your host operating system and run it in the network namespace of the PHP container, so you can access any website which is available only on localhost inside the container. For example, you have an admin dashboard and you don't want the admin dashboard to be available from the outside world. You only want it to be available inside the container on localhost. Now imagine that you don't use curl, but you use a web browser. for example, Firefox, Google Chrome, or any of your favorite web browsers. You can still access the admin dashboard inside the container. Now that we know more about the namespaces, we can also talk about the network traffic between the container and the outside world. And your container is running on your host operating system, and your host operating system usually has an interface which is connected to the outside world. And the outside world in this case can be the internet or your local network. If the container wants to communicate with the outside world, it needs to have its own interface. And this interface will be connected to another interface, virtual Ethernet interface on the host. So this is how the host can communicate with the container. And this virtual Ethernet interface on the host could have an IP address, but Docker uses another approach. It will create a bridge interface, so your traffic from the virtual Ethernet interface will go to the Docker bridge, and from the Docker bridge, it will go to the interface which is connected to the outside world. And this is how your container can reach the internet. But sometimes you don't want the container to be able to access the internet or your local network, and this is when you can use internal Docker networks. To be able to use an internal Docker network, you need to create a user-defined network. You can create this user-defined network with the internal flag, so it will be an internal network, which means that the network traffic will not be forwarded from the Docker bridge to the outside world. So let's try this in practice. And I prepared a command that I can run in my terminal, but I'm using my MacBook, so I have a Mac OS and I need a Linux operating system, so I will start a virtual machine using multipass. Multipass shell docker VM. And now I can run this command. And the next step, I will check the network, docker network ls. I can see that I have my secure_net, and I want to run a simple bash container using the network secure_net. And the image I want to use is bash, and I will use a specific version like 5.1, and let's see what happens. I have my container and I want to use ping, and I want to ping the DNS server of Google. As you can see, it doesn't work because we don't have internet access. And if I try to see the IP addresses inside the container, you can see that I have an IP address. Now I exit from the container and I will try this same command without the private network. Let's use ping again, and it works. When we are talking about the network, the Docker network, then we have to talk about another interface, a special interface called loopback interface. And this is what you usually refer to as localhost. And you need to know that the localhost is different in each namespace. So when the PHP process is listening on localhost inside the container, you will not be able to access that PHP process, that PHP website from the host operating system using your web browser or even curl on localhost. And you will have the same problem if you have, for example, a database server listening on the host operating system on localhost, and you want to access that database server from inside the container using PHP. The localhost on your host operating system and the localhost inside the network namespace will be different, so you will not be able to do that. If you want to solve it, you can, for example, use the host network, which doesn't mean that you will use a special network which is connected to the host. It will mean that you don't want the isolation of the network, so you don't want to get a different network namespace. If I run this command, you can see how it works. So if I can type this command properly, I can run this container. We have to wait until it is downloaded. Okay, and now I will check my container if it is running, and I have two containers, and my first container is Portainer. It was not installed by me. It is the default installation inside the Docker virtual machine using multipass. If I now run docker exec -it, or I don't even need this -it, so I can just run docker exec php hostnet IP ADDR, then I can list all of my interfaces available on the host operating system. So this is when we don't use network namespace at all. I don't want to keep that container, so I will delete it. And we can continue with the next example. So this is what happened. We have a PHP container without the network namespace and a database server running on the host operating system, and the local host of the host operating system and the PHP process is the same. But we are using Docker container because we want isolation. So another solution could be using another container and using the same network namespace as the PHP container. I will run this container again with a different name, and let's run it. Let's check if it is running. Yes, it is running. So I have a container and I want to run another container. This is not a database server, of course, but just a simple bash container. So I will run this container, but I will also use the network option. And after the network option, I will use container :php. It means that I want to use a network namespace of a container, and the name of the container is PHP. So let's run this one, and we can see that the IP address of the PHP container can be seen from the bash container. Let's just check it. Docker exec php IP ADDR, and we can see the same IP address. So we finally started to play with network namespaces, but Docker is not the only way to do that. So we can learn about the IP command nsenter and also unshare. And the first command will be nsenter. This is useful when you want to run a process, a command inside a namespace, and you have an existing process or at least an existing namespace. And in my first example, I will need a process ID, and I want to run IP ADDR inside my PHP container. So let's get the process ID of this container. Let's check if this variable is right. Okay, I have a number. And now I can start my first nsenter example running IP ADDR. I need sudo because using network namespaces requires to be a root user, and because I want to access the network namespace of the PHP container, I need to use -n, and I need to pass the process ID to -t. And after the process ID, I can use my argument, which will be executed inside the namespace. So let's press enter and see what happens. So we can see the IP address inside the PHP container and all of the available interfaces. Let's go back and try another command. In this case, I want to get the hostname of the container. If I run this command, it will give me the hostname of my host operating system. So now the problem is that even though the hostname is related to the network in our head, it is actually not part of the network namespace, it is part of the UTS namespace. So what we can do is that we can use -u after -n. So we can use the UTS namespace of the container. Let's run this one and you can get the hostname of the container. We can also check this by running docker exec php hostname, and we get the same. The nsenter command is great if you have an existing process or an existing namespace. But what if you don't have an existing network namespace? You can use ipnetns command to create new network namespaces and also execute other commands inside this new namespace. So my first command that I want to run is ipnetns list. And if I run it, I will see nothing. And the reason is that the ipnetns command tries to read a folder called /run/netns. And we have nothing inside this folder. And if you try to see the namespaces of Docker, you need to run sudo ls /run/docker/netns. And two of these namespaces are the namespaces of the running containers. And we also have another namespace called default. Let's see what this default namespace is. And to do that, we need to learn how to use nsenter differently than we used before. Let's run sudo nsenter. And now I need to use --net instead of just -n, because now I want to pass the file name, the file path of the namespace, which is /run/docker/netns/default. And if I run ipADDR, I can see the IP addresses and interfaces on my host operating system. It does not mean that the host network is a special network which is connected to the host operating system. It is still the lack of the isolation. Docker just uses this default network for some reason, but I don't know the reason. If you know the answer, please don't hesitate to share it under the video. It's time to finally create our first namespace, first network namespace, and to do that we can run sudo ipnetns add test, so our first namespace will be called test. Let's run ipnetns list again, and we have our first namespace. We can also check the folder /run/netns, and we have the file there. We can also use the ipnetns command to execute a command inside that test namespace. We need ipnetns exec, and now we need to pass the name of the namespace, which is test, and after the name of the namespace we need to pass the executable command, which is ipADDR. And I can try to run it, but I will not be able to, because again I need sudo to execute something in another namespace. If I run it, I can see that I have a loopback interface without an IP address, and I don't have any other interfaces. Even though I know the result, I want to show you some commands so I can prove it that the container doesn't have any internet access or any network access. Let's run sudo ipnetns exec, and I want to use ping inside the container. I will ping dns.google, and I will get this temporary failure in name resolution error. And you could think that this is the problem of the name resolution, but if you use the IP address instead of the domain name, which I will show you, then it will not work either. We don't have any network. So because this namespace is pretty useless, we can just delete it. Let's use sudo ip netns del test. We can also try a different command, but a very similar command. So let's use unshare. Unshare is for creating temporary namespaces for processes that you want to run in a secure environment. In this case, I want to unshare the network namespace, so I will use all of the namespaces of the host operating system except the network namespace. If I run this command, I will get the same result as I got when I run the ipnetns command. We don't have network interface. But this can be useful if you just want to run an application which you know that doesn't need to use internet or any network, and you want to make sure that it is not able to use that. So far, we only use the IP command to manage new namespaces that we have just created. But what if you want to manage the namespaces of Docker? You can do that, and I will show you how. First, I want to try to remove this /run/netns folder. And I can tell you that I will not be able to. As you can see, it says this device or resource busy. So sometimes it is just enough to exit the shell and open a new shell. We have used the IP command to list the namespaces inside /run/netns, and we also use the ls command to list the files inside. So something is still using this folder. If I just exit the shell and try it again, and I run it, I will get the same error message. So the next that I can try is that I can reboot my system. Let's do that. Now I want to show the status of my virtual machine. So let's run multipass list and watch it. Okay, it is still restarting. It is finally running. So let's go back and try to remove this folder again. And now I don't have an error message. It looks like I managed to remove this folder. Let's check it, /run/netns, and it does not exist. And the next that we need to do is we need to create a symbolic link instead of a folder. So let's run this next command so we can create /run/netns as a symbolic link, which will point to /run/docker/netns. Let's run it. And if I run ls, I will see just the link. Even if I use a slash after the folder, I will see that I don't have a permission to list the content, and this is because now this /run/netns is just a symbolic link to a folder which I don't have access to without sudo. So let's use sudo. And what you can see here is that I have only one namespace here, and this is because I had container which was running when I started the virtual machine, and my PHP process is not running, so I can run start docker start PHP, and list the namespaces again. And now I have two namespaces. I can also use sudo IP netns ls, and I can see the namespaces of my Docker containers. Of course, you don't want to reboot your system in case you have a production server, so you need to find another solution. I want to restore my netns folder, my default netns folder, so I will unlink my symbolic link and create it again as a folder. In this case, I don't want to make the netns folder symbolic link. I only want to link individual files from the folder of Docker. So I can run the following command to get the file path of the namespace, and this is called sandbox key. I can check it, sandbox key, and there is a little difference between this file path and the file path that we've seen before, because we have seen this /run/docker/netns, and now we have /var and everything after that. If you check the root file system, you can see we have a folder called run, and we also have a folder in the var folder, and this is just a symbolic link pointing to the run folder in the root. Now we know the file path of the namespace that we want our symbolic link to point to, but we also need a file name that we can create under /run/netns. So I go back and get the end of the previous path, the sandbox key, which is the name of the namespace. Okay, and after that, I can use the following command to create the symbolic link. If I run sudo IP netns list again, I can see only one namespace in the list, even though I have two containers. Now that we know the name of the namespace of the container, we can run the following IP netns command to execute IP-addr inside the PHP containers network namespace. We can see the IP addresses of the PHP container. So let's go back and try another command. Let's try to ping an IP address. It works. And now let's try to ping a domain name. And now we get our old error message, temporary failure in name resolution. So we could ping an IP address, but the name resolution doesn't work. And if you want to understand the reason, I have to go back to my diagrams. So let's talk about what happened here. We tried to use the ping command inside the network namespace of the PHP container. And the ping command requires some configuration files to tell the ping command what the IP address of the name server is. We use only the network namespace of the PHP process and not the mount namespace. So the ping command can only see my files on the host. My host operating system is configured to use a local IP address to communicate with the actual name server. If we want to solve this, we can try to change the configuration on our host. Let's try that first. And this is important to know that you should not do this unless you know that you will not break your system and you know that you can recover if something goes wrong. So I will run it only on my test virtual machine And the first that I need to do is that I need to find out what this file actually is. So I will run this read link. And now you can see that this file, this etc/resolve.conf, is actually a symbolic link. Let's see the content of the symbolic link, or the file that it points to. And now you can see that it contains a local IP address. And we have another file as well here. And this is called just resolve.conf, which contains the IP address of the name server without the local IP address. So the solution is that I want to remove this symbolic link, the original symbolic link, and then create a new symbolic link. And this symbolic link will point to the other resolve.conf, which contains the actual IP address of the name server. If I try to run my previous netns command again, I will be able to ping dns.google. Okay, I don't want to keep that configuration, so I will remove the etc/resolve.conf again and restore my original symbolic link. Let's test it again. And again, it doesn't work. So this was our first solution, and we have another, which is something that will not affect our host operating system, only the network namespace in which we want to run our command. So we can create a new folder. And before I run it, I want to make sure that my netns variable is still there. netns. Okay, I have the value, so I can run this command to create a new folder under etc/netns, and the new folder name will be the name of the namespace. Okay, so this is the namespace of my PHP container, and I need a file in that folder. Of course, I need root user sudo nano and the file name, and I will set the not the namespace, the name server to the IP address of Google's DNS server. So the next command is the ping command again. If we run it, it works again. Before I go to the next example, our next solution, I want to remove this previously created folder because I don't want you to think that our next solution works only because we have this custom configuration file. So let's remove this. And now we can do our next solution. At this point, you can pause the video and go out to drink your coffee or tea or whatever you like. And when you come back, you need to pay attention because this solution will be very tricky. In this solution, we want to change the content of the resolve.conf file without actually changing the original file. So to do that, we want to create a new folder, which will be our playground, And we also want to use a new folder called root inside our playground. Now we want to bind mount the original root file system into this new root folder. And this will only work because Linux has some special folders like proc, dev, sys, and also run. And the run folder is on tmpfs, which means everything is in memory. And when we bind mounted the original root file system, we only got the original file system without the tmpfs, which was mounted when our operating system booted. Since our run folder inside the new root folder will be almost empty, we can actually create a new file inside, so we can create our new resolve.conf. And now let's do that in practice. Just because I want to make sure that all of my variables are there, I want to set them again. And I need the sandbox key and also the process ID of my PHP container. I also want to set a project there. I want to create it. And I want to cd into it. Let's see the next step. So I want to create a new folder called root, so I can mount the root file system into my new root folder. And before I mount the root folder, I want to see the content of the root. And of course, I know that this will be empty, but I still wanted to show you that. And when I run the following command and check the content again, I will see the same result that I would see when I run ls/. We can try this. I will check the content of root run, which has only 2 folders. And if I run this ls command to see the content of my original run folder, I see something completely different. And the next step is that I want to create another folder, and this will be the place of our new resolve.conf. And I could do that because, again, my root run folder contained only 2 folders, and I could create my new systemd folder. Now I want to create my stubresolve.conf as an empty file, and this is because if I try to see what the etcresolve.conf is, okay, not this way, so I can use the ls-l. Now it shows me that this etcresolve.conf is a symbolic link pointing to the stubresolve.conf, and the problem is that I cannot override this etcresolve.conf as a symbolic link. I can only override the target of the symbolic link. So even though I need the content of the resolve.conf and not the stubresolve.conf, I will create the file as stubresolve.conf and copy the content of the resolve.conf. Let's see that. So the next step, I will copy resolve.conf to my local folder. Let's check it. Resolve.conf, it's there. And I will bind mount this file on top of my previously created empty file. So we have finally finished almost everything. So the last step is running the nsenter command. And now we have to learn something new again. We have to learn that we can actually change the root file system when we are running nsenter, so we can choose a new mount namespace. So the mount namespace will use this root folder as a root file system. Let's run it, and this works. Now I want to clean up, so I will mount using sudo. I will mount the root run systemd resolve start-resolve.conf. I can also remove that empty file. Of course, I need sudo again. Now, actually, I can remove the systemd folder as well, so I can just run sudo rm -r. Okay. Now let's mount the root folder. It will be empty now. And finally remove the root folder itself. The next example is something that I call debugging the Minotaur. And I call it because we did something similar before when we ran a container using another container's network namespace. In this example, we don't want to use an entire container to run our command in another container's network namespace. We only want the mount namespace of a container. So we will have a debug container, and we use only the mount namespace of that debug container, and we will have a PHP container, and we only want to use the net namespace of the PHP container. So as the next diagram shows you, I will use all of the namespaces of the host except the mount namespace and the network namespace. And to do that, I can use the Nikolaka netshoot image, which is a very useful image if you want to have many tools to debug networks. For example, you can have the tshark or tcpdump as well. So I want to run the following command. It will run in the background. I also need to use -i because I want to use it as an interactive container. Otherwise, it would just start and exit immediately, but this interactivity will keep the container alive, the shell alive inside the container. So let's start the debug container. Now we have it. So let's see the next step. Again, we have to learn something new. And this is that we can access namespaces a different way that we used before. So far, we only used the network namespace as a sandbox key of Docker, but we can also find the processes under the proc folder, and if we know the process ID, then we can find the folder which has the name as a process ID, and under that folder we will find the ns folder, and under that we will find something like mnt, net, and pid, and the mnt is the mount namespace, and the net and pid I think is obvious. So let's just see that. Again, I need my sandbox key because I want to use the network of my PHP container. So I will use the old way to get the namespace, and I will get the process ID of the debug container, so I can also use the new way. Okay, let's check these variables. PHP sandbox key is there, and debug pid is there. So let's use nsenter. And using nsenter, I can use the dash dash mount option as well. We already knew about the dash dash net option, and now we can use the net namespace of the PHP container and use the mount namespace of the debug container. Okay, so let's run this ping command, which will ping the IP address or the domain name of Google's DNS server. It works. Of course, this is not something that is interesting enough to do, so let's do something more interesting. You can run tshark. As I mentioned before, tshark is installed inside the Nikolaka netshoot image. And let's run this tshark. So tshark can listen on the ETH0 interface to show me the network traffic. And of course, I need to generate some network traffic. So in my other terminal window, which I have not used before, I can enter the virtual machine, Docker VM, and I need the IP address of my container. Okay, let's try again. So copy this line. Yes, I have the IP address, and now I can use curl to get the content of the website. And in the other window, you can see the network traffic. Of course, you need to know what these lines mean, but if you know that, you can have a very powerful tool to debug your containers. It's time to use what we learned before. So what if you want to run an application without internet access in a container because you don't trust that application? And if that application is a web-based application, you need a web browser. If the application is using JavaScript on the client side to redirect you to another harmful website, then you can be in trouble. So what you can do is that you can run your web browser in the network namespace of the application and use either the network none option or the internal network. If you are using the network none, it means you will not have any network inside the container, only the loopback interface. So the PHP process, for example, can listen only on this loopback interface, and since your web browser is running in the same namespace, it will be able to access the PHP application. Since I don't have a web browser in my virtual machine, since this is just a server virtual machine, I can't use a web browser here, but I can use a similar example. So I will start a new PHP container. I will call it PHP networkless, and I need to use the network option with the value none. Let's do this. Okay. And the next command, again, I have to get the process ID of this container. I have it. And I can use nsenter to run curl localhost inside this namespace. Let's try another solution using the internal network. In this case, our web browser can be on the host operating system. It also means that if the application uses a JavaScript to redirect us to another website, it will be able to. But if I use curl instead of a web browser, it will not interpret the JavaScript, so I can use it safely. So let's create an internal network. We already have an internal network, but we can create another. and I will call it just internal. Okay, something happened with my terminal. I hope it was created correctly. Let's check it. Docker network ls. Okay, I have my internal network. And I can check if this is actually internal. Docker network inspect internal. Internal true, so it is correct. The next step, I will run my new container called php internal, and after the network option I will use internal. Let's get the IP address of this container and use curl to get the content. It works as well. Up until now, we only talked about Docker Community Edition and not Docker Desktop. Now let's talk about Docker Desktop, how you can use our previously learned tricks in case of Docker Desktop. So let's say we want to use network none. It means you will have your host operating system and the host will have its own local host. You will also have a virtual machine created by Docker Desktop. This virtual machine have its own local host, which is different than the local host of the host operating system. And you will also have a local host inside the PHP container. So what it means is that you will not be able to access the localhost inside the network namespace of the PHP container because you can run your web browser only on your host operating system. Even if you are using the internal network will not let you forward ports to the IP address on the internal network. So you cannot use the web browser on the host because you obviously need to forward the port to access a container inside the virtual machine. So we need a different solution. If I can scroll down, I can explain it to you, and you can also read the explanation about this diagram, but let's talk about the diagram. We know that we want to run our application in a container without internet access, and we know how to do that. We also know that we want to run the web browser in the network namespace of our application, and the problem is that in this case we need to run a web browser inside the virtual machine. And the good news is that we can actually run a web browser in a container, but the problem is that we have to access the graphical interface of the web browser. And the other good news is that we can use the Linux server Firefox image, which contains Firefox and also a remote desktop server. So we can use a remote desktop client to access the graphical interface of the web browser, which is actually in the container which does not have internet access. And now the problem is that we still need to access the remote desktop server. So the solution is that we can run another container which can connect to the internal network and also the public network. And this will be a proxy container. So we can open a web browser on the host and connect to the proxy server, and through the proxy server we can actually connect to the remote desktop server, so we will use the web browser as a remote desktop client. You will only get the graphical interface of the web browser, but not the actual traffic. So you can safely run any website inside the container, which is using the same network namespace as the PHP container. Okay, so after this explanation, let's do it in practice. This time I need another project folder, and now I don't need my Linux operating system. I can exit the virtual machine, and let's create a new variable for the new project folder. Again, you can change it if you want to. I will create this folder and cd into the folder. I will check the content of the folder. This is empty. Okay. I have an example project that you can download from GitHub. You can just use this command here, and you can also see the content directly here on the website. I will create a default network as an internal network. I will also create a public network. My first service will be the PHP container. I do not want to specify any parameter here. I know that this will use the default network, which will be an internal network without internet access. And I want to run a Firefox container using the network mode. This is very similar to what we used before when we used the -- network space container colon PHP. The difference is that we have Docker Compose now, and now we want to run a container, a service, using the network namespace of another service. So we can just use the name of the service and not the name of the container. And the last container, the last service, is the proxy container. I will use the Alpine socket image to run this proxy. And you can see here this simple command which will forward any TCP traffic on port 3000 to the PHP containers port 3000. So because we want to access the port 3000, which is a port of the remote desktop server, I need to open this port. So I use this port forward. And this container needs to have access to the default network, the internal network, and also the public network, which lets this container to have a port forward. Okay, so let's run this command from GitHub. Yes, I want to paste it and run it. Now I have my compose file. Perfect. And what I want to do now is using Docker Compose up-d. Okay, I have my service and Docker Compose project. So I can try to access this from my web browser on port 3000. Now I actually have my Google Chrome web browser on my host operating system, and I have my Firefox web browser in the container. Let's try to open a website in the container. Localhost will be enough. It is trying to load my website. Okay, so this is the result, and it could be the actual result, but it is not. So let's see the inspect option here in the web browser. Go to the console tab, and you can see multiple error messages, and this will show you that something is happening inside the container. It tries to access files outside of the container, and it tries to download something from the internet. Since these files are not harmful, I decide to run the container with internet access. So let's go back to the previous screen, and run the following command: php internet. It will listen on port 8080. It doesn't work because I have already created a container with the same name, so I want to remove this. php internet. Let's run again. Okay, it runs. I will open a new tab here and let's run localhost 8080. And this is the actual proper result of this application. And now you can use it and the JavaScript will work. You can click on the buttons here, run some of the examples and read about the examples. So this was everything I thought you should know about network namespace and namespaces in general, at least so far. You can also go to the ITCGAT, learn docker itcgat.who, and browse the other menus as well. You can also try some examples, or if I continue to add more advanced topics, you can come back and read those too. I also have some sources here that I used to create my presentation, and when I was almost done with my presentation, I found a very useful article that you can read, and I recommend you to read this. It will also explain how you can create the network interfaces inside the container. So let's read that too and learn more about Docker containers and the network namespace.